Alright, so that's it. So you can just comment in the chat and let me know if you're hearing me or you're seeing the page properly. Alright, Giovanni. Alright, so now we don't have a lot of time until the 11:30 break or 11:30 lunch that you guys want. So let me just do the revision and then we can get into the objectives for today. So put it here. Alright, so Pythagoras theorem. So Pythagoras theorem, the formula is a squared plus b squared is equal to c squared. So what the formula is useful for is to find the missing side of a right-angled triangle. So that's the usage of the formula. Whenever you have a right-angled triangle, you have three sides, but with Pythagoras theorem questions, they're going to give you two sides, and from those two sides, you're going to be required to find the missing side. So, in the formula, you have A, B, and C. So, what are A, B, and C? So, let me draw the triangle to show you. Alright, I'm now to the page. Alright, let me get blurry still. Alright, should be better now. Should be better. Alright, so Pythagoras theorem. So we have the formula a squared plus b squared is equal to c squared. So with the formula for the Pythagoras theorem, we deal with right angle triangles. So these are the triangles we use it when we're dealing with Pythagoras theorem. Where is it? Oh, it's so blurry. Yeah, so these are the formulas. These are the triangles that we use Pythagoras theorem for. Right angle triangles. So we know for the right angle triangle we have a hypotenuse. So this is the hypotenuse over here. It's dark. Is it better now? Because I think that's the best I can get it for now. No, but I just you would still have to get the lesson, so you know. Actually, we're getting paid to do it here, but you just find your own method. So alright. So this is the hypotenuse. So the hypotenuse. So hypotenuse, that's the longest side of the right angle triangle. So you can make a note of. So while I write, you can write as well. So the hypotenuse is the longest side of the right angle triangle. So the longest side. Then over here, this is what we call the height. I normally label it as, so this is the height over here. And then under here is the base. So that's how the right angle triangle looks. You have the height, you have the base, and you have the hypotenuse, which is the longest side. So the formula is a squared plus b squared is equal to c squared. Now, how I label it, this is my a over here for the height. My base is b, and my hypotenuse is c. So let me just draw it under here without the labels. So my base is b, my height is a, and the hypotenuse, which is the longest side, that's my c. So if I was given an example to calculate the missing side, let's say for example I have to calculate the missing side for the example that was given in the activity, the question I was given in the activity. So over here, the height was 20, the base was 5. And we were asked to calculate the missing side. So to calculate the missing side, we'd use the formula which says that a squared plus b squared is equal c squared. Alright? Then what we have to do is identify what a, b, and c values are. So what's the value for a? What's the value for a? We're using this triangle right here. What's the value for a? Alright, so the value for a is 20. So over here we have a. So a is equal to 20. What's the value for b? Alright, yeah, 20. So that's good. So the value for B is 5. So B is equal 5. And C is unknown. So we can call C X. So now we have everything we need for the formula. We have A, we have B, and we have C. So our next step now is to input into the equation. So the equation is A squared plus B squared is equal to C squared. So wherever we see A, we're going to put 20. Wherever we see B, we're going to put 5. So we see A there, so we're going to put a 20. So it's going to be 20 squared. We see B there, so we're going to put 5. And B was being squared. C, we don't know the value for C, so we're going to put X. So we put an X here. Now 20 squared, what's 20 squared? 20 squared is, anybody in the chat want to comment? What's 20 squared? Devisha, Shanice, what's 20 squared? Alright, so 20 squared, that's 20 times 20, that's going to be 400. And 5 squared is 5 times 5, that's going to be 25. So it's going to be 400 plus 25 is equal X squared. So since we have it that it's not the square root of 20, I meant like, 20 raised to the square, 20 raised to the 2. So then we're going to have 425 because the formula is C squared. So wherever we see C, we put X and we're going to square it. So now we have 400 plus 25 is equal X squared. Then we're going to add it. So 425 is equal X squared. But we don't want X squared, we want X. So we have to find the square root for both sides. So the square root of 425 is equal to the square root of X squared. And we know the square root of X squared is just X, which is what we want. So that's why we found the square root of X squared. And the square root of 425 is 20 point, I don't have my calculator right here with me, but it's 20 point something. Now for the second example. So the second example is where a lot of people always get trapped or get tricked. So for example, I'm giving a different question. So we have 5 for the height, the hypotenuse is 8, and the base is unknown. So this is how we're going to do it now. So for those of you who are still writing, you can just write this off. It's the same thing as the answer. The answers that I sent in the group, it's the same thing. So you just write it off. Alright, so now, this is a similar question. And guys, don't leave the chat. We're going to go to the objectives. I'm just going over this for the persons who were absent. So we find A, B, and C now. So A is equal 5. B, we don't know what B is. So B is equal to something like X. You can call B anything. It's a variable, so you can give B any name. And C is equal to 8. So what we do now, we write the formula, which is A squared plus B squared is equal C squared. We substitute the values into the formula. So wherever we see A, we're going to put 5. Where we see B, we put X. And where we see C, we put 8. So we're going to have 5 squared plus X squared is equal 8 all squared. So now 5 squared, we know 5 squared is 25. Javania, you remember do your recap on your left class? Alright. So 25 plus X squared is equal 64, and we want X squared by itself. So since we want X squared by itself, we're going to bring the 25 over. It's going to become negative. So it's going to be X squared is equal 64 minus 25. X squared is equal, no, it's not so much. So that's going to be 1, 4. So it's going to be X squared is equal 41. So then we have X squared is equal 41. Then we take the square root of both sides down here, and we get X is equal to 6 point something. So that's how we do Pythagoras theorem. Now we're moving on to the trig ratios. So the trig ratios, as we discussed last term, that's SOHCAHTOA. So we're going through the objectives now. So the first objective was to identify the trig ratios. So trig ratios, SOHCAHTOA. So it's so ka toa. So those are the trig ratios, so ka toa. Now, what so ka toa means, as you probably most of you remember, sine of theta is equal opposite over hypotenuse. So O is for opposite, H is for hypotenuse, S is for sine, C is for cosine, A is for adjacent, H is for hypotenuse. And over here T is for tangent, O is for opposite, and A is for adjacent. So we say, so for the so ratio, sine theta is equal opposite over hypotenuse. For the ka ratio, this one is gonna be, alright, so why is that blurry now? Alright, let me just catch this good. So for ka, so ka, its cosine is equal adjacent upon hypotenuse. And for toa, which is this one, it's gonna be tangent is equal opposite over adjacent. Now, what these ratios are useful for, they're useful to find missing angles and they're useful to find missing sides. So whereas with Pythagoras theorem, you only use it to find missing sides, you use these ratios. Sir, we can't see the book. Set the camera good. Alright, Ashanik, you're still lost. You mean from the Pythagoras part or from the ratios part? Ashanik. From the Pythagoras or the ratios part? I think the book is good now. Alright, so let me just go over the Pythagoras theorem really quick since you say you're lost. Really quick. Alright, so with Pythagoras now, it was that we were looking at finding a missing side. With trig ratios, we can find missing side and we can find missing angle. So Pythagoras, we have the hypotenuse, which is the longest side, we have the base, and we have the height. So height is A, base is B, and the hypotenuse is C. So the formula is A squared plus B squared is equal C squared. So that's the formula for Pythagoras. Why is this blurry now? Alright, so this part is blurry. Sir, my lost. Sir, we have to square it when we have C. When we have to find sir, we have to square it when we have C. So yeah. So that's it. So this one, Ashanik, so it's A squared plus B squared equals C squared. So we know A is 20, we know B is 5, so we can find C using the formula. So that's how it goes. Alright, so now regarding the ratios, regarding the trig ratios, so we have so ka toa. So we can use trig ratios to find, start over please. Alright. Start over from Pythagoras from yesterday. Alright, so Pythagoras theorem, we use it to find the missing side. So when we're calculating the missing side, a triangle has 3 sides because you know triangle. So we can find the missing side if we know 2 of the sides. So if we know any 2 sides, we can find the side that is missing. Now, here, this is how I label it. So I label it like A, B, C. So height is A, base is B, and the hypotenuse is C. The hypotenuse is always going to be the longest side. Now the formula says A squared plus B squared is equal C squared. So that's the formula. So we have A is equal 20 because of the formula. So we know A is 20, B is equal to 5, and C is unknown. So we call C X. So B is equal to 5 and C is unknown. So we're going to write it down. So when we write it down, we have A is equal 20, B is equal 5, and C is equal X. So therefore, we have a squared plus b squared is equal to c squared, which is the original formula. So wherever we see a, we're going to put 20. Wherever we see b, we're going to put 5. So we see a, so we say 20, and a is being squared, so we put the square back. We see b is 5, so we put the 5 and put the squared up top, is equal x squared. Now, 20 squared is 400, and we're going to add 5 squared to that. 5 squared is 25. So we have 400 plus 25 is equal to, remember c is equal to x, so is equal to x squared, because the formula is a squared plus b squared is equal to c squared. So we have 425 is equal to x squared. Now, since we have 425 squared is equal to x squared, we don't need x squared. What we need is x. So we're going to find the square root for both sides. So we find the square root for 425, and we get 20 point something, and we find the square root for x squared, and we get x. So therefore, x is equal to 20 point whatever, I think 20.8. I'm going to go for my calculator shortly. So now over here we did another example. We're given a is equal 5, b is equal x, c is equal 8. So we write that down. A is equal 5, b is equal x, c is equal 8. Then we're going to put into the formula, which is a squared plus b squared is equal c squared. So where we see a, we put 5, and a is being squared, so we have 5 squared. Where we see b, we put x, and since we have b being squared, we have to square the x. And where we see c, we have 8, so where we see c, we're putting 8, and we square it as well. So now we have 5 squared, which is 25, x squared, which is x squared, is equal to 8 squared, which is 64. But we want x by itself, so what we have to do is some linear equations. So what we have to do is linear equations. So we're going to bring the 25 over, so bring numbers with numbers, variables with variables. So you bring the 25 over, and because it's positive, it's going to be a negative 25. So now we have x squared is equal to 64 minus 25. Then 64 minus 25 is 41, so x squared is equal to 41. Find the square root for x squared, and find the square root for 41, so we have x is equal to 6 point whatever the answer is. So that's how it works for Pythagoras theorem. Alright, I'm losing some people. So